Welcome to our class on trigonometry. Today we are going to take a look at trigonometric identities and proof techniques. Okay, so equations usually come to prove identities, and when we are solving trigonometric equations, we will need to prove some identities to simplify the solution. Okay, so we are going to look at the proof techniques and their identities. Okay, so by the end of this lesson, I'm going to make sure you are going to recall and apply key trigonometric identities. Okay, so there are certain identities you should remember. Okay, so I'm going to make sure you're able to recall them and you're going to be able to apply them. Then the next thing is we are going to prove identities using algebraic manipulation and substitution. Okay, so we're going to do some substitution to trigonometric identities, and you're going to algebraically manipulate using factorization so that you prove the identities. Okay. Then we are going to simplify expression. Okay, so we're going to use the identities to solve problems. Okay, so we're going to simplify expression so that they can be easily worked upon. Okay, so this is it for today. So make sure you are going to finish this lesson so that you don't miss anything, and make sure you're subscribed. Let's start by learning about some basic trig identities. Okay, so given the trig identities, okay, so when I talk about trig, I mean those cos, sine, and tan. Okay, so we're going to use this. So let me look at the basic ones. Okay, so the first thing is a tan x. Okay, let me use theta. We're going to be using theta as our variable for n. Okay, so tan theta is equals to sine theta over cos theta. Okay, so you should remember that tan theta is equals to sine theta over cos theta. That's one of the identities. Then the other thing is cot theta. Okay, cot theta is equals to 1 over tan theta, which is going to result as cos theta over sine theta. Okay, so you have to remember this. Okay, so tan theta and cot theta here. Then we have the other thing, which is cosec theta. Cosec theta. Okay, so in this case, it is 1 over sine theta. Okay, so this is what we call cosec theta. When you see cosec theta, you can substitute it with 1 over sine theta. Then we have sec theta. Okay, sec theta, it is 1 over cos theta. Okay, so you can substitute this and this. Okay, so these are the basic trig identities we are going to be using. Okay, so make sure you remember this, and I'm going to add some which are more advanced, but these ones are the best. Okay, so every time when you see tan theta, you can substitute it with this, and every time when you see cot theta, you can substitute it with this or this, and this when you see cosec theta, you're going to substitute it with 1 over sine theta, and when you see sec theta, you're going to substitute it with 1 over cos theta. Okay, so this is the basic of trig identities. Okay, so we're going to look at other identities. So make sure you are able to remember them, memorize them, and be able to recall them. So let's start from the Pythagorean identities. Okay, so this is an identity which was derived from an equation of a circle. Okay, an equation of a circle says that x squared plus y squared is equals to 1. Okay, so this is an equation of a circle of radius 1. Okay, so this is when a circle has a center at 0, 0, and has a radius 1. This is the equation of a circle. Okay, so this equation was derived from that circle. Okay, so if you see that circle, let me try to draw it. Okay, this is the circle. Let's assume that it has a radius 1 here. Okay, so if we draw a triangle here, you can see that this is 1 and 1. Okay, so you can see that this x is equals to cos x, cos theta. Okay, if our angle theta is going to be here, angle theta is going to be here. This x is going to be cos theta, and this y is going to be sin theta. Okay, so substituting this in this equation, we're going to get an equation which is called sine squared theta plus cos squared theta is equals to 1. Okay, so this is the first equation you have to work from. Pythagorean identity number 1 is this one, sine squared theta plus cos squared theta is equals to 1. Okay, then we can modify it. If you want to modify it, you can divide all of this with sine squared theta. Okay, so let's divide. It becomes sine squared theta divided by sine squared theta plus cos squared theta over sine squared theta is equals to 1 over sine squared theta. Okay, so after that, you're going to see that you're going to get 1 here. So it's going to become 1 plus, and you see that here cos theta over sine theta is going to be cot theta. Okay, so if we square it, it's going to become cot squared theta. then equals to 1 over sine theta. I told you that is going to be cosec squared. Okay, so it becomes cosec squared theta. Okay, so this will be our trig identity 2 coming from this one. Okay, so if we choose again to divide by cos theta, okay, we can do the same procedure, and you are going to come out with an equation which is tan squared theta plus 1 is equals to sec squared theta. Okay, so this is it. So we can see that these are Pythagorean. All of them, they come from this one. Okay, so in this case we divided by sine theta, and in this case we are going to divide by cos theta to this equation, and we're going to get. Okay, so I'm going to be substituting this in identities to prove them or simplify them. Okay, so I'm going to do an example. So make sure you understood this so that you can remember this. Just try to remember this one, and to get this you have to divide by sine theta, and to get this you have to divide by cos theta. Okay, so let me do an example. I'm going to take a simple example so that you can know how or what is it. Okay, so the first thing you are going to say sine squared theta sec squared theta minus tan squared theta. Okay, so we are asked to simplify. Okay, so simplification is making sure that we only have sine and cos to an equation. Okay, that is what we call simplify. If you have sine and cos, you can say that you have simplified. Okay, so let's go on and substitute each of this we know. Okay, so the first thing is sine squared theta here. We know it. Okay, so sine squared, you don't affect it a lot. Just leave it like that. Okay, then sec squared. I told you that sec squared is 1 over cos squared theta. Okay, then you say minus. Here we have tan squared theta. I told you that if it's tan squared theta, we're going to say sine squared theta over cos squared theta. Okay, so tan is sine over cos. Okay, so if it is squared, we're going to square all of them, sine squared and cos squared. Okay, yes, sec is 1 over cos theta. Okay, so this one is squared. Okay, so we're going to square 1 and cos squared theta. Okay, so this means that our answer is going to be sine squared theta over cos squared theta minus sine squared theta over cos squared theta. Okay, so by substituting and manipulation, we have seen that we have reached here where sine squared over cos squared is subtracting sine squared over cos squared. Okay, so now we can see that our answer is there. Okay, so this was that simplification. You are given this expression, but you just have to substitute what you know, making sure that everything goes to become cos and sine. Okay, so this is the basic you can do. Convert everything to become cos and sine. Okay, so from that you can simplify it easier. Okay, so here we can see that we have our expression here. It has come to give us here. Okay, so that was that. We are coming from Pythagorean identities. Now we are going to see angle, sum, and difference identities. Okay, so if we add an angle, what is going to happen? Okay, so the first one we are going to use sine. We're going to take on sine. Okay, if we say sine an angle, let's say an angle A plus an angle B. Okay, so we're going to take sum and difference. Okay, so let me do difference here, plus or minus here. Okay, so what are you going to do when you say angle A plus B or angle A plus angle A minus B? Okay, so this gives us an identity which look like, if we simplify this, we have to remember here, it gives us an identity which is sine A multiplied by cos B plus or minus. Okay, so look how here plus or minus, and here is plus or minus again. Then here is going to be sine B cos A. Okay, so this is what it is. Okay, it's just changed here from this identity. It goes to this one. It becomes sine A cos B plus or minus sine B cos A. Okay, so this is it. If you get an angle which is like this, to simplify it, we have to substitute like this one. Okay, so let's go to the next one, which is cos. Okay, so if it is cos an angle A plus or minus B. Okay, so here it changes. Okay, please note the changes. Okay, so what it does here, it says cos A cos B. Okay, then here it says minus or plus. Okay, so this means that when it is plus here, it is going to give us minus here, and when it is minus here, it's going to give us plus here. Then here sine A, sine B. Okay, so this is it. Make sure you are noting out these signs, the difference here. You are noting out the difference here, and you are noting out that here you say cos A cos B, then here sine A sine B, and here you are saying sine A cos B. Oh, please make sure you are paying attention to the differences. Okay, then the other thing is we go here to 3. Okay, so the 3, let's say it is an angle which is saying tan A plus or minus B. Okay, so please pay attention. When it is tan like this, what we do is we say tan A plus tan B. Okay, plus or minus here is like the same. Tan A plus B here is the. Then we say over 1 minus or plus. Okay, so in this case, when it is plus here, you're going to put minus here. When it is minus here, you're going to put plus here. Minus or plus tan A, tan B. Okay, so these are the identities for sum and differences. Okay, so we can use this to substitute wherever you see two angles being added. You just substitute it to become this one so that you can simplify it easily. Or when you see them in this side, you can substitute them back to this one and you can solve. Okay, so these are identities for sum and difference. Okay, so let's go on to look at double angle. Next, we are looking at double angle identities. Okay, so when you say double angle, we are saying that the angle is being multiplied by 2. Okay, so let's start with sine. Okay, so I'm going to do some proof so that you can grasp it better. Okay, so let's say the first thing is a sine A, sine, let's say it is going to sine 2 theta. Okay, so in this case, this angle is 2, is multiplied by 2. Okay, so what is the answer? Okay, so the answer on this angle is going to be 2 sine theta cos theta. Okay, so but I can prove this so that you won't be confused. When you forget, just prove this using the sum and difference. Okay, so you know that 2 theta is theta plus theta, right? Okay, so you're going to get sine theta plus theta. Okay. Okay, so from our identity which says that sine A plus B is equals to sine A cos B plus sine B cos A. Okay, so this was our identity. Okay, so let's apply this here. But now we just have to make sure that A and B, they are all theta. Okay, so we can apply here. So it's going to become sine theta cos theta plus sine theta cos theta. Okay, so now you can see that we have sine theta cos theta and sine theta cos theta. So it's going to give us 2 sine theta cos theta. Okay, so this is our equation for double angle. Okay, so if you get sine 2 theta, just know that we are going to just take 2 here and put it out and include cos. Okay, so it becomes 2 sine theta cos theta. Okay, so let's go on to the next one, which is 3, which is the second one. Okay, so here let's say we are given cos 2 theta. Okay, so the identity of this one is going to give us something like this: cos squared theta minus sine squared theta. Okay, so this is it, cos squared theta. Okay, so please try to solve it like this using the difference and sum we did on the previous one. Okay, so, and try to prove that this one is equal to this one using the same equation I used. Now just use for cos. Okay, so if you have get it, just comment proven in the comment section. Then let's go on to the next one, which is the third one. Okay, so the third one is tan 2 theta. Okay, so given tan 2 theta here, you can memorize it or you can use that double angle, that difference and sum we did on the last chapter. Okay, so in this case, we are going to get an equation like this. It's going to be 2 tan theta 1 minus tan squared theta. Okay, so this is it on our double angle. Okay, so when you see sine 2 theta, just know that it's 2 sine theta cos theta. And when you see cos 2 theta, just know that it's a cos squared theta minus sine squared theta. And when you see tan 2 theta, just know that it's this one, this fraction. Okay, so please, you can remember this or you can try to prove it on your own. Before we go any further, let's try to prove something. Okay, so let's say I give you an equation which says that prove that cos 2 theta is equals to 1 minus 2 sine squared theta. Okay, so we're going to prove this. Okay, so we're going to apply everything we get. Okay, so the first thing I can tell you is you have to try where there is a double angle. Okay, so I'm going to give you tips of proof in the next chapter, but the first thing is you start where there is a double angle. Okay, so we're going to start this side and go this side. Okay, so let's say you are starting with the left hand side. Okay, so we are going to say cos 2 theta. Okay, so we have our identity of cos 2 theta. We said that if you get cos 2 theta, it's going to be cos squared theta minus sine squared theta. Okay, so this is it for the identity. Okay, so now we want to make sure that this one equals to this one. Okay, so we do remember when we did our Pythagorean identity, we said that cos squared theta plus sine squared theta is equals to 1. Okay, so in this case, you can know that here we have sine theta. Okay, so this means that we have to eliminate this cos. Okay, so we're going to substitute this cos here. Okay, so we can eliminate it by saying cos squared theta, by making it subject to formula here, is equals to 1 minus sine squared theta. Okay, so now you see, we just have to substitute this to this one. Okay, so here we took it from Pythagorean. Okay, so we took it from Pythagorean. Now we're applying it here. From this one, we made cos squared theta a subject of formula. Okay, so here let's say go on and substitute cos squared theta. It becomes 1 minus sine squared theta, then minus sine squared theta, this one. Okay, so now we're going to get 1 minus 2 sine squared theta. Okay, so this is it. We know that this one is now equal to this one. Okay, so we can now say it's proven. Okay, we just took this side and we used every identity we know, and we used some common sense here that we know that our solution it is not going to involve cos. Okay, so if you take here, we're going to remove this cos by making it subject to formula and substituting here, and now our substitution is going to come easier. Okay, so this was that on the proof. You can close this and try on your own and come back and see. Now, let me give you some proof techniques. Okay, so I hope this will help a lot. Okay, so just follow them. Okay, so the strategy is this. The first thing is we are going to start with the more complex side. Okay, given an equation with two sides, we are supposed to prove this side is equal to this side. Okay, you find the more complex side. Okay, so this is the side you are going to simplify. Okay, so then next we are going to express all functions in terms of sine and cosine. Okay, so we're going to make sure that every term is a sine or a cos so that it is easy to simplify, either cos squared, either sine squared, but you're going to make sure that every side is a sine or a cos. Then the other thing is you're going to use algebraic techniques. You're going to use factorization, common denominator, and every algebraic technique you know to simplify to make sure that it is going to be equal to our answer. Then the other thing, we're going to substitute known identities. Okay, so I've told you identities which are Pythagorean, double angles, and the sum and difference. Okay, so we're going to substitute these ones in our equation. When you see it, substitute it. When you see it, substitute it, and try to solve our answer until we get our answer. Okay, so we're going to do this example. This example applying this technique. Okay, so the first thing is let's make sure that this one becomes a linear. Okay, so let's make it linear. Let's cross multiply. Okay, so we're going to get 1 plus sine x, then 1 minus sine x, then is equal to cos squared x. Okay, so this is about if we simplify this. Okay, so now our duty is simple. We just have to find the more complex side. In this side, I can say this one is more complex side. Yeah, if you agree with me. Okay, so this is the complex side. Okay, so now let's see how our algebraic techniques we know. We did this. We started with the complex side. You see that we've done it. We are going to start with this one. Okay, so let's write left hand side. Then here we're going to see all functions in terms of sine and cosine. Okay, so now see that here we can see that all of them are in terms of sine and cosine. Okay, next we are going to use algebraic techniques. Okay, so our technique we can see here, we can see a difference of two squares. It's 1 plus sine x, and here you can see that it's 1 minus sine x. Okay, isn't it? We are just going to use this. Okay, so this is a difference of two squares. Okay, so what do we do here? We know that if you see a term that like this, it's just 1 minus sine squared x, isn't it? Okay, this is it. Okay, if you try to expand it, you can try to expand. Okay, you can try to expand this multiply by this multiply, but I'm sure you're going to get to go here. Okay, so here we just use difference of two squares, and you saw that it's going to become this. Okay, and now we just have to substitute the identities we know. Okay, so now we know that on this side we have cos. We want to go to cos. Okay, so this means that we have to eliminate this side. Okay, so from our equation we know that sine squared theta plus cos squared theta is equals to 1. Okay, so this is our Pythagorean. Okay, so we're going to use this to substitute here. So let's make sure that we want to remove this sign. So you're going to be sine squared theta is going to become 1 minus cos squared theta. Okay, so let's substitute here. let's substitute sine squared theta with 1 minus cos squared theta. Okay, so this means that we are going to get 1 minus, then 1 minus cos squared x. Okay, in this case it's x. This is our variable x. Okay, now let's go on and see that we have substituted this sign. Okay, so now we can see it's 1 minus 1 minus times minus, it becomes plus cos squared theta. Okay, now we see that 1 minus 1 becomes 0, and we are only left with cos squared theta. Okay, so now we have cos squared theta, which is equal to this one. Okay, so now we can say it's proven. Okay, so this is it. We just have to use our manipulation of algebra and make sure we substitute the known identities. Okay, so this was our known identity, and we just substituted sine squared x here to become 1 minus cos squared x. Then we simplified and become our answer. Okay, so that was that on proof and identities. Okay, so the easier way to make sure you remember all this is by practicing. Make sure you practice many identities to prove, so that you end up recalling every aspect of identity. Okay, so this was that. Thank you for watching. Now it's time for you to subscribe so that you won't miss out the next lesson.